Okay, so this is going to be on types of reactions. I will say this, okay? I'm not going to tell a story. If you have other teachers, they're going to probably tell a story a way that for you to remember things, okay? And that's why we have Abby and Bill up here and whatnot. I am not going to do that, okay? So we have, I believe right now, 5 types of reactions. 5 types of reactions: synthesis, decomp or decomposition, single displacement, double displacement, and combustion reactions. I froze on that one again. If you watch the example video, you know what I'm talking about. So in this case, I want to focus on this right here, our general form. Okay, we have 2 or more combining to make a new compound. So 2 becoming 1. Okay? Generally, it's how it looks. And if you look at our examples down here, we have this plus this yielding this. 2 things making up something new. So when that happens, copper has its own properties, chlorine gas has its own properties, toxic, and they form and they combine to have new properties. Okay? And we'll focus here, it says new compound. So there's no such thing as A and B on the periodic table. A and B are supposed to be like algebra, where we use like X, right, to represent something. So it just represents one compound and another compound come together to make a new compound, 1. Okay? And our examples balanced. How nice is that? 2 becoming 1, 2 becoming 1, 2 becoming 1. Synthesis reaction. Okay? Now, what's decomposing? Decomposing is breaking down. So our next one is decomposition. So instead of going from together or apart to together, we go from together to apart. You can see she's crying. They broke up. This guy says I'm free, which is fantastic. It's so funny. I didn't notice that before. So anyway, we have one thing, our AB becoming 2. Okay? AB would have a set of properties. A and B by themselves would have a new set of properties. Okay? Here's our examples down here. Okay, I think you could see those. One thing yielding 2 things. 2 or more things, I should say. Okay? A lot of times, whenever I do examples in class, they always have 1 yielding 2. But we could have 1 forming, 3 different compounds or elements at the end. Okay? This is an interesting one, like right here, because this is water, and if you put like an electric current through it, you get hydrogen gas and oxygen gas. You might be seeing videos on that where they then take the hydrogen and they light it on fire, and it forms a gas ball. But you could have reactions that go both ways, So in this case, we could also have these 2 things combining to go that way. But you see this arrow? This arrow means that this is the reactant. These are the products. So 1 to 2. All right. Now, I think the next one's single displacement. There's another girl that gets involved here. But anyway, single displacement. Okay. I always call it single displacement. Some people I've heard say single replacement before, and you can use either. Basically, you could see this girl, she replaces this girl. So you see we have A, B, and carbon is a C. So C basically comes in here and knocks out A. All right? And you can see it right here in the general form. Okay? You could see it in the general form that C replaced A. If C replaces A, then C needs to go first. Here's why, and it mentions it down here. If C knocks out A, it must mean that C was a positive oxidation. So it was a metal. Remember, our first element in an ionic compound is a metal. So if this one's a positive metal like sodium or magnesium, it would knock out whatever this is. Okay? Now, can C ever knock out B? Why not? Okay, well, here's our first two examples, okay? Now, you'll notice, go back here for a second. You see how it says AB plus C? Realize, right, you could also have C plus AB, okay? It's just like math, you know, 2 plus 3 is the same as 3 plus 2. Those are our reactants in any order that they are, okay? Doesn't change which one's going to be knocked out just because the order. So here, calcium is 2 plus, if you remember that, okay? If it's an ion, if it's going to be an ion, remember the magnesium is the 2 plus, so the calcium knocks out the magnesium. You see that over here? And then magnesium is positive, and so it's going to knock out the positive hydrogen. Knock it out. Okay. This guy. Who's this guy with the top hat? Chad. So, in the first one, recall, if you look at it, it says that C, a metal or hydrogen. Okay. Now, this one is telling you that C is a, I don't know if you could read that. It's a non-metal. So if we have our AB now, B is the non-metal, so C is going to knock out B. And then we have AC plus B. Okay? Same reasons as before, just opposite. Like, it sounds weird, but same but opposite. So they're the same, like, reasons. They're both negatives, so it knocks it out. But the first time they're positive, now they're negative. Okay? Read through this. Look at our examples. Fluorine is over here on the periodic table. Way over here. It's a negative ion if it's an ion, so it's going to knock out chlorine, which is the negative ion, and replace it. Okay. Single displacement, again, they call it version 2 because the first version dealt with knocking out the cation, the positive ion, and the second one knocked out the anion, the negative one. Double displacement. I don't know why I like double displacements. Not because of anything up here. I don't know why. Just to me, it seems simple. Okay? And here's the reason why. This one is always positive, negative. C is always positive, D is always negative. So which ones are going to flip? You're going to just put D with A, you're going to put B with C. Okay? One thing you got to be careful about here, though, is remember the positive one always goes first. So when B goes over here and knocks out D, or however you want to look at it, whatever's knocking whatever one out, you got to remember that B is going to come second because that was our negative, right? So A is positive still, D is still negative, C is positive, and B is negative. Okay? Oh, it says right here. Always written first. All right. So let's take a look down here. There's just swapping going on. So here's our positive, here's our positive. Ag and Na. So Ag is going to go with the Cl. Look at that. And then Na is going to go with the NO3. Look at that. Over here, that's Ki, potassium iodide. And then this is lead, Pb. And that's odd one, right? Plum, or however it's pronounced. And I think it's Latin. So lead is positive. Potassium's positive. And they switch. So lead's going to go with the I. K is going to go with the NO3. Now, the one thing that people might look at and they're like, oh, this is weird. You see how this is Ki and then this is PbI2? Remember, you're going to have different numbers down here for subscripts because of oxidation numbers. Okay? Lead is a 2 plus in this case. K was only a 1 plus, right? So you need more I's to kind of neutralize that over here. But anyway, K and Pb, they switch. And then the big one here. Combustion reactions to me are frustrating when we go over them and when they're on a test. Because I always tell students, the first thing I would look for in any reaction that we have, if you see CO2H2O at the end, combustion reaction. First thing I look for in every single one. Okay? So, you can read it. These are called hydrocarbons. That says CXHY, which just means there's going to be some number down there, right? C8H4. Who knows, right? And then you're always going to be in the presence of oxygen. If you remember, like, if you have candles and you're going to put them out, like in a church, you put the You don't smother them by hitting them. You just put the, I don't know what they're called, but you put the little cup over top of the flame and it puts it out because there's no oxygen left. So you have to have oxygen for the combustion to happen, and it's going to produce carbon dioxide and water. Okay, there's our example. There could be all kind of numbers here on the C and the H, the hydrocarbon. Oxygen, gas, carbon dioxide, and water. Okay, you could look at that balancing tip, but it's okay. All right. Now, here's our abbreviations. Not very difficult. Synthesis, S, S. Decomp. You'll hear me say decomp a lot because it's shorter, obviously. D. I normally put SD, DD, and then C. Okay? Single displacement, double displacement, and combustion. I think students a lot of times like replacement because one is replacing the other, but displace means the same thing. If you've been displaced from your home because of a fire, you're moved out of the home, okay? You have to go somewhere else. All right, so these have the same meaning. All right, so that's it for types of reactions. And I would recommend, if you want to hear a good story from about the relationships and the breakups and whatever, you can talk to a different teacher so they could tell you that story.